Hi everyone, let's take a look at the following. So in the last two videos we did part D and E, and in this third video we're moving on to part F. Sketch the following. F of x equals to x divided by x squared minus 1. Step number 1. Before we write down the domain for the function, by inspection, because it's going to be a fraction or a rational expression, you can write down all the possible asymptotes. The fact that x squared minus 1 is in the denominator, this means the restriction is x squared cannot equal to 1, x cannot be plus or minus 1. And because x cannot be plus or minus 1, the vertical asymptotes are located at x equal to plus and minus 1. And likewise, if you look at the exponent at the top and at the bottom, notice the bottom has a large exponent or a larger exponent than the top, which means there is a horizontal asymptote at y equal to 0, which implies there will be no oblique asymptotes. So now you can write down the domain. X is an element of real numbers such that x cannot be plus or minus 1. And again, here's a reminder. Domain is related to its vertical asymptote. Range will be related to its horizontal asymptote. To find the critical points, you have to find the derivative, set it to 0. In this case, again, it's a fraction. You can use the quotient rule. Step 1, square the bottom. Step 2, copy the bottom to the top. Step 3 can multiply by the derivative of the top. Second last step, you can copy the top, and the final step, multiply by the derivative of the bottom. Now again, there are two columns. We're going to divide this two, and you want to focus on the top, which will give you x squared minus 1 minus 2x squared. And in the second column, you can look at the denominator. Again, anytime the derivative is undefined or does not exist, those values may be critical points. But again, I mentioned that most likely if you found a vertical asymptote, the vertical asymptote continues to carry into f prime and f double prime respectively. So let me just finish the second column. This means if I did solve for x squared equals to 1, then x would have been plus or minus 1. But again, we wrote down the fact that those are vertical asymptotes, so those will not be part of the critical points. If you go back to the first column and you collect by terms, negative x squared minus 1 equals to 0, x squared equals to negative 1. Now this is really important. A lot of students, when they do their homework or when they're doing something on a question on a test, on a quiz, on the final exam, and they can't find the when they can't find the critical point, they make this correlation that they made a mistake. And that's simply not true. Just because you cannot find a critical point, it does not mean you made a mistake. In fact, for this function, there are no critical points, which means there'll be no maximum, no minimums, and that's perfectly okay. That's perfectly okay. Now you carry forward and you kind of say, well, I can still move on to increasing, decreasing. Notice how even though there are no critical points, the anchor point is going to be the asymptotes. So I don't know why I wrote down 0. I'm really thinking negative 1 and 1. So again, you still want to divide them by the vertical asymptotes. I'm going to take a step back. I did mention always graph as you go. Let's demonstrate that. So in the first part, when we found the asymptotes, I forgot to label them immediately. Let's go back and make some adjustments. So x equals to negative 1, x equals to 1, y equals to 0. We're now reconnected. So again, this I'll leave to you. It's really important that you try some of this with me. You can figure out what happens when x is less than negative 1, when it's in between negative 1 and 1, when it's greater than 1. Press pause. You can plug it back to f prime. Again, in this case, f prime is going to be negative x squared minus 1 divided by x squared minus 1 quantity squared. And when you press play again, I'll be right here. Okay, so when you plug numbers back into f prime, you should get the following: decreasing, decreasing, and decreasing. Now let me write this back for you. We did write this in the lesson, and I want to write this again for you. I didn't really write this as much for the last two videos, just because I want to squeeze as much as I can, and in this one we have a bit more time. So interval of increase, none. You got to write down none. If you leave it blank, it doesn't mean it's none, it just means you didn't write it. And of course, there's two ways to express this. The interval of decrease occurs when x is less than -1, when it's in between -1 and 1, or when it's greater than 1. Now, another student's going to say, no, can I write it like this? X is an element of real numbers where x cannot be plus or minus 1. That's fine. So you pick the one that you're more comfortable with. Either case works. Now, if you move forward to the next step, you have to find the inflection points before we talk about concavity. And again, to find the second derivative, you apply the quotient rule one more time. Step 1, square the bottom. Step 2, copy the bottom to the top. Step 3, multiply by the derivative of the top minus, copy the top, and you multiply by the derivative of the bottom. And again, notice how there's a chain rule inside the quotient rule. You set this to 0. Again, there are two columns you're focusing on, not only at the top, but you're really setting 0 to the bottom. And sometimes you do get critical points or inflection points. And in this case, f double prime is undefined or does not exist. But because we found vertical asymptotes, this means even though x is plus or minus 1, but we knew these are vertical asymptotes, so they cannot be inflection points. If I go back to the numerator, again, I can factor this. There's a common factor of 2, x squared minus 1. In brackets, it's going to be, I can even factor a negative. So -2, x squared minus 1 at the front. In the brackets, that's going to be x times x squared minus 1. If I keep going, plus 2 times negative x squared minus 1. And I think there's an x here too, just like that. Now again, it's okay if you can't find inflection points. Do not fall under the impression that you always find critical points and you always find inflection points. So again, if you divide this into two different columns, in the first column here, effectively this is again what we found already, which are the vertical asymptotes. So this is not any inflection points. And here, if you expand this, x squared minus x minus 2x cubed minus 2x equal to 0. This will give you negative 2x cubed plus x squared minus 3x. Now there is a common factor of x. In the brackets it will be negative 2x squared plus x minus 3. So there is one inflection point, x equal to 0. Again, you can plug it back in and you discover that the actual location is at 0, 0. So again, in this case, or in this function, there were no critical points, no max or min, but there is one inflection point. And this part, I believe, will not work. Let's just confirm that. If you apply the quadratic formula, negative b plus or minus square root of b squared minus 4 times a times c divided by 2a, you would discover there's no solutions here because under the square root, this is 1 minus 24, and it's a negative number. So again, it's perfectly okay that this part doesn't work, but there is an inflection point, 0, 0, which we're going to go back to. So let's add this back in, 0, 0. Now, again, if you continue with concavity, you can draw a line, and don't forget the vertical asymptotes, -1 and 1. Don't forget the inflection point, 0. and you can plug it back in to figure out when it's concave up and concave down. I'll leave it to you to work this out, but this would give you concave down, then it's going to be concave up, then it's going to be concave down, then it's going to be concave up, just like that. Now, again, let's just write this down for the sake of consistency. Therefore, it's concave up when it's less than -1. It's concave up when it's in between -1 and 0, when it's greater than 1, and therefore it's concave down when it is less than -1 or when it is between 0 and 1. Now, the most important piece, and this is the second last step before we put the graph together, you look at all these points and you've got to take the superposition or the overlap, right? So there's, -1, 0, and 1, just like that. And I'm just going to copy this, right? If you go back to the decreasing line, it was decreasing, 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 which we're going to copy, just like that. Likewise, from above, we know it's going to be concave down, concave up, concave down, concave up. Again, press pause. Draw the 4 parts. When you press play again, you see the answers. Here we go. So when it's concave down decreasing, it would be like that. Concave up decreasing, concave down decreasing, concave up decreasing. You take all those parts and you put them together. So it's going to look something like this. Same idea. This part's going to be concave up. That's going to be concave down. And of course, that's going to be f of x. Don't forget to label this point, inflection point, just like that. And this is how you graph f of x equal to x all over x squared minus 1. I hope this makes sense.